Hello everyone. For this video, I will be discussing polynomial interpolation using Microsoft Excel. So this is the part 1 of my video and I will be discussing the simplest method in polynomial interpolation. So let's start. A polynomial interpolation is a method of interpolation done by obtaining the lowest degree polynomial that passes through all given points. If there are n plus 1 ordered pairs in the data, the lowest degree of the polynomial that can connect these points is n. So for example, a data of 4 pairs can be connected by a polynomial to the third degree. So what we're trying to achieve when we are doing polynomial interpolation is that we are trying to interpolate, or we're trying to generate a polynomial equation wherein kapag pinag-graph natin yung polynomial equation na yun, yung magiging graph niya or yung magiging curves ng graph niya is magpapass through all the given points in the data. So these given points, ito yung tinatawag nating ordered pairs. And the important thing na kailangan tandaan natin dito is, sabi dito, for n plus 1 ordered pairs in the data, the lowest degree, the polynomial that can connect these points is n. So kaya nga, kapag meron tayong 4 pairs of data, sabi dito, it can be connected by a polynomial to the third degree. Why? Kasi sabi, n plus 1 ordered pairs is parang, ang n dito is yun yung lowest degree ng polynomial natin. So, if we are trying to equate the ordered pairs to n plus 1, so n plus 1 is equals to 4. Para masolve natin si 4, all we need to do is to subtract 1 from 4, and therefore our n will be 3. So, kasi 4 minus 1 is 3. So, at the same time, kapag meron naman tayong 5 ordered pairs, so it can be connected by a polynomial to the 4th degree. Kasi 5 minus 1 is 4. So, parang yun lang naman yung pinaka main importance ng sinasabi ng statement na ito. So, let's proceed now to the one of the methods in doing a interpolation of polynomial. So we have here the Newton's divided difference method, and it is said that the Newton's polynomial for nth degree polynomial is defined as y is equals to f of x, which is equals to a sub 0 plus a sub 1, quantity x minus x sub 0 plus a sub 2, quantity x sub minus x sub 0, multiplied by the quantity of x minus x sub 1, plus ellipsis, plus a sub n, quantity x minus x sub 0, quantity x minus x sub 1, and then ellipsis, x minus x sub n. And where the coefficients are defined as, so ito yung mga coefficients natin, we have a sub 0, a sub 1, a sub 2, and so on and so forth, we have a sub n. So these are all the formulas for the coefficients. So a sub 0 is equals to f of x sub 0, which is also equals to the y sub 0, and a sub 1 is equals to the inverse delta y sub 0, which is equals to y sub 1 minus y sub 0 all over x sub 1 minus x sub 0, and then a sub 2 is equals to inverse delta squared y sub 0, which is equals to inverse delta y sub 1 minus inverse delta y sub 0 all over x sub 2 minus x sub 0. So kung mapapansin nyo, parang magkakaroon lang naman siya ng pattern here sa formula because it follows a model equation of a sub n is equals to the inverse delta raised to n y sub 0, which is equals to the inverse delta n minus 1 y sub 1 minus inverse delta n minus 1 y sub 0 all over x sub n minus x sub 0. So, kung titingnan natin itong mga binigay na formula sa atin, so parang mahirap siyang tandaan, and at the same time, mahirap din siyang i-interpret. So, that's the very reason why kung bakit mas mainam na gumamit tayo ng tabular representation ng mga information na to, instead na i-follow natin yung conventional way na kailangan sundin natin yung mga every variable and letter na nandito. So, kasi kapag ginamit natin yung tabular representation, doon natin nasasabi na madali lang naman pala talaga yung process ng Newton's divided difference method. So, I will show you here the sample of the tabular representation. So ito, the value of the divided difference, the inverse delta m of y sub I is computed recursively. So when we say recursively, gumagamit tayo ng data from previous calculations in order for us to calculate the next data. So para makapag-arrive daw tayo sa next data, gumagamit tayo ng information from the previous data. So thus, it is recommended to perform the calculation with the aid of tables. Ito na nga. For example, the tabular presentation of the third degree polynomial is shown below, where ito yung ordered pairs natin. We have the x and the y. So for every ordered pairs, it is labeled as x sub 0, y sub 0, x sub 1, y sub 1, so on and so forth. We have hanggang x sub 3, y sub 3. And we also have here our inverse delta y hanggang inverse delta raised to cube y. So kapag fourth degree polynomial naman, all we need to do is parang nagdadagdag lang tayo ng another column, and at the same time, nagdadagdag din tayo ng another row. So instead na meron tayong hanggang x sub 3, y sub 3 lang, nagkakaroon tayo ng x sub 4, y sub 4. And we also add another column here, which is the inverse delta raised to 4 of y. So parang ganun lang yung establishment ng table natin, and para mas maintindihan niyo kung paano nag-work itong table natin, I will give you an example problem, and doon ko na rin ituturo kung paano nga ba nag-work ang Newton's divided difference method using the Microsoft Excel. So I have here a problem, a sample problem for the polynomial interpolation, where specifically ang gagamitin natin is the Newton's divided difference method. So a mechanical engineer is testing the temperature behavior of a steel rod inside an industrial furnace. During the experiment, the rod's thermal expansion, which is in millimeter, is recorded at different temperatures, which is in degrees Celsius. The measured data are shown below. So we have here the values of x, and we have here the values of y. So as you can see, meron tayong 1, 2, 3, 4, 5 ordered pairs. So therefore, the lowest degree of polynomial that can connect all these points is the fourth degree polynomial. So sabi dito, you need to estimate the thermal expansion of the steel rod when the temperature reaches 225 degrees Celsius. So all we need to do, or parang ang sinasabi lang naman dito, we need to find for the value of y when x is equals to 225. So para mahanap natin or solve natin yung pinapahanap ng problem, we have to employ the process of polynomial interpolation. Specifically, gagamitin natin itong Newton's divided difference method. So siguro ipapakita ko na sa inyo yung process kung paano siya nag-work using Microsoft Excel. So lipat ko lang. So ito yung pinakita kong problem sa inyo kanina, wherein kinakailangan natin gawin is we need to solve for the value of y when x is equals to 225. So ito yung tabular representation ng Newton's divided difference, wherein magagamit natin to in order for us to generate the interpolating polynomial that would help us solve for the value of y when x is given to be 225. So kanina in-explain ko naman na kung bakit mas mainam na i-present natin siya into the table form, so that mas simplify natin yung solution, and hindi na tayo mag-worry na mag-memorize pa ng mga complex formulas. So using a tabular presentation, mas mapapadali natin yung computation natin for the Newton's divided difference method. So the first thing na kailangan natin tandaan dito is itong mga naka-dark colored cell, ito yung mga cell na hindi natin kailangan punan ng value or hindi natin kailangan lagyan ng value. So madali lang naman siyang tandaan actually. So for the inverse delta y, since meron tayong imaginary one na naka-raise sa inverse delta dito, so parang ang indicator nun is merong isang cell dito na hindi natin lalagyan, which is starting from the topmost cell, and then the rest is merong laman or merong value. And for the inverse delta squared na column naman, so meron tayong squared or 2, so meron tayong dalawang value from the topmost na hindi lalagyan ng value, and the rest meron. And likewise for the inverse delta cube, tatlong value na wala, and then dalawa meron or the rest is meron. And for the last, we have the inverse delta to the fourth. So meron tayong apat na value na hindi lalagyan, and yung last cell dito is meron. So, paano ba natin i-compute yung mga values dito sa mga light colored cells na to? Since itong mga light colored cells na to is sila lang yung merong values. So, it follows actually a pattern, and once na magets na yung pattern niya, madali na lang siyang ma-compute. So, let's solve first for this column, yung column ng inverse delta y. So, first we need to establish a formula. So, para magawa natin yun, of course, equal, and then ito lang yung gagawin natin. So, open parenthesis muna tayo. For the Newton's divided difference, actually, kaya siya tinawag na Newton's divided difference kasi we are trying to get the ratio of two differences. So, yung difference nitong column na to, and then difference ng column na to. So, parang ganito siya nag-work. So, first, itong value na to, which is kapantay lang nito, minus itong value na to. And then all over, so i-close parenthesis muna natin siya. And then all over, or divided by, and then close open parenthesis, and then ito, this value minus itong value na to. So parang ganun lang yung pattern niya. Kukunin lang natin yung difference na to, 1.86 minus 1.24, and then all over 150 minus 100. So, as you can see, palagi tayong nagsisimula sa baba bago dun sa taas, or papunta tayo sa taas. Kaya 1.86 minus 1.24, then 150 minus 100. So, the next thing we need to do is just to press equal para makuha natin yung value. So, we have 0.0124. Now, yung sunod na gagawin natin for the next cell, or for the next cell of this column, is parehas lang naman ng ginawa natin dito. So, this time we need to get the difference of 2.51 minus 1.86 all over 200 minus 150. So, ganun lang ulit. Pero, para mas mapadali yung process ng pag-solve natin, hindi na natin kailangang ulitin pa yung pagsulat ng formula na yun. Since nagawa naman natin siya dito sa cell na to, all we need to do is just to drag this cell downward hanggang sa pinakababa para makopy lang yung formula and mag-compute na siya automatically. So, pag ginawa natin yun, so, automatically, it will compute for us the values na kailangan natin for this column. So, let's try to solve for this column naman, the inverse delta squared y. So, para masolve natin yung sa column na to, almost the same lang siya sa process na ginawa natin dito sa unang column, but dito sa unang column na inverse delta y, yung first difference na kino-consider niya is the differences in y, wherein kapag dito naman sa inverse delta squared y, ang i-consider nating differences ng numerator natin, or yung unang differences, is ito naman ng differences naman ng inverse delta y. So, kumbaga, ito para dito, ito naman para dito. So, ganun. So, let's establish first the formula. So, equal. So, open parenthesis. So, ito, again, minus. Ito naman. So, palaging una yung nasa baba bago yung nasa taas. And then, all over. Or divided by. And this time, kung dati, ang kinukuha natin is just yung katabi or nasa taas na value ng x, so 200 nga minus 150. This time, for the inverse delta squared y, ang gagawin na natin is we need to jump twice pataas para makuha natin yung next na value, para makuha natin yung value na is-subtract natin from the value na kapantay nitong row na to. So, parang ganito siya. Mas makuha nyo. So, 200 minus, so instead na 150, we need to jump twice pataas. So, 1, 2. Kaya, ima-minus natin siya not from 150 but from 200, from 100. So, ito, 200 minus 100 and close parenthesis natin. And therefore, the next thing we need to do is just press equal. So again, to recap lang, ang ginawa natin dito for the inverse delta squared y is kinuha natin yung difference ng column na to all over the difference ng column na ito. So, para hindi kayo malito kung ilang jumps ba yung kailangan natin para makuha yung difference na i-require natin for the x value na kapantay ng row na sinosolve natin. So, you need to remember na kapag 2 ito or yung exponent ng inverse delta natin is 2. So, it means kailangan natin mag-jump ng twice pataas. Kaya 1 and 2. So, that's why in-employ natin dito kanina yung 200 minus 100 instead na mag 200 minus 150 tayo kagaya ng ginagawa natin dito sa first column. So, pag pinag-click ko na yung equal yung enter dito, makuha na natin yung value na kailangan natin for this cell. So, that's a valid value. So, actually, that's a value almost close to 0. It means 6 times 10 raised to negative 6. But since yun yung binigay sa atin na value, so okay lang naman yun. So, siguro nagkaroon lang ng problema sa problem natin. But since yun yung binigay ng Excel, so I think that's correct value naman. So, for this cell naman, same thing. Ganun din naman yung gagawin natin. Kagaya ng ginawa natin dito sa cell na to. But sabi ko nga kanina, para hindi na tayo magpaulit-ulit na mag-type ng formula, all we need to do is i-drag na lang natin to pababa hanggang dun sa pinakababang cell na required para mahanap natin yung certain na value. So, drag na lang natin to hanggang dito, and therefore, it will automatically solve for us the value na hinahanap natin for this column. So, meron na tayong value. And now, for this column, ganun pa rin yung gagawin natin. We need to solve for the differences, but this time, ito, para naman dito, and still, para din all over pa rin naman sa value ng x or the difference in x, but this time, since this inverse delta cube, and it is raised to 3, so thrice na tayong mag-jump pataas. So, parang from 250, mag-jump tayo pataas sa 200, 250, 1, 2, 3, so sa 100 tayo magbabawas. So 250 minus 100, parang ganyan yung setup natin. So, let's establish the formula once again. So, ganun ulit. Itong value na to, minus value na to, and then all over 250 minus 100. Okay, lagay ko lang sa parenthesis para i-treat siya ni Excel as 1 to. And pag pinag-click ko yung equal, it will give me the value na kailangan ko for this column. And since uulitin ko lang din naman siya for this cell, ida-drag ko na lang siya pababa para hindi na ako mag-ulit ng formula. And finally, para makuha ko yung value na to, ganun pa rin naman. Kukunin ko yung differences, but this time, dito naman ako with respect to this column naman. And palagi pa rin akong kukuha ng differences kay x, but this time, since raised to 4 na siya, so I have to jump 4 times pataas. So parang 300, 1, 2, 3, 4. So 300 minus 100 ang nasa denominator ko. So that is equal to, again, open parenthesis, then the differences nitong dalawa. So ito minus ito, and then all over 300 minus 100. So parang dulo-dulo na siya, no? So pag nasa last column na to, always yung denominator natin is the difference nung kada dulo ng row natin. Therefore, kapag pinag-equal ko to, it will give me the value that I need for this column. Now, since na-establish na natin yung tabular representation for the Newton's divided difference, ano naman yung silto na to? Now, since meron tayong dito ang general formula, pwede na nating ma-establish yung interpolating polynomial natin para ma-solve natin yung specific value ni y at any value of x, or at a certain value of x that falls under the span, not itong 100 to 300. So, yun pala, nakalimutan kong i-remind sa inyo kanina na yung x natin, it doesn't we don't require the x column to be arranged in an increasing or decreasing manner. So kahit ano yung order na dito, okay lang yun, and we can still establish the Newton's divided difference method table, and masasolve pa rin naman natin yung makukuha pa rin naman natin yung interpolating polynomial, and we can still solve for the value of y. So ang sunod natin na gagawin is we need to look at the main diagonal of this table. So ano itong main diagonal na sinasabi ko? So ito itong mga main diagonals, itong mga values na to. Ito ang tinatawag kong main diagonal, starting from the initial value of y, which is the y sub 0 here, and then pababa itong diagonal na to. Ito yung mga coefficients ng main diagonal natin. So i-highlight ko lang yun para makita nyo na. So to so bakit binigyan ko ng emphasis yung main diagonal nito? Kasi based sa formula, itong main diagonal nito, ito na yung magiging coefficients na hinahanap natin. So 1.24, ito na yung a sub 0 natin. 0.0124, ito na yung a sub 1. Itong 6 times 10 na raised to negative 6, ito na yung magiging a sub 2 natin. So on so forth, hanggang sa coefficient ng pinakalas na value natin. And diba, dito sa general formula, it follows a certain format na a sub 0, ito wala muna siyang multiplier, but for the a sub 1, meron na siyang multiplier na x minus x sub 0. Now, ito ang x sub 0 natin, x sub 1, x sub 2, x sub 2, x sub 3, and x sub 4. So, parang pasunod-sunod lang naman ito dito. X minus x sub 0, then plus a2, which is ito na yung value ng a2 natin, then x minus x sub 0, which is ito na naman, x minus 100, tapos x minus x sub 1, which is x minus 150, and so on so forth. Mas-establish na natin yung interpolating polynomial natin na required for this problem. So since na-establish naman na natin yung table for the Newton's divided difference method, and nakuha na natin yung mga kailangan natin dito, which hinighlight ko siya. Ito yung mga hinighlight ko. Main diagonal values natin, which will serve as the values for the coefficients na kailangan natin for our interpolating polynomial. So this is a sub 0, the a sub 1, the a sub 2, a sub 3, and then the a sub 4. So para masolve na natin yung value ni y, we just need to follow the general formula for establishing the interpolating polynomial, and then by considering that the value of x is equals to 225, masasolve na natin si value ni y. So to do that, establish lang natin yung formula or the interpolating polynomial for x is equals to 225. So i-follow lang natin itong general formula natin. So we have equal, so a sub 0 muna, which is ito, and wala siyang multiplier. So proceed na tayo sa a sub 1, so plus a sub 1 plus a sub 1, and this time meron siyang multiplier na x minus x sub 0. So itong multiplier natin for every coefficient, actually it does follow a pattern. So for example, ito x minus x sub 0, ito yung x sub 0 natin. So all the values of x, ito yung mga tinutukoy ng formula natin ng x na merong subscript. So ito x sub 0, so ito yan, x sub 0, since yung mga subscript natin, it follows an order starting from 0 hanggang sa 4, since for this problem hanggang 4 to. Kaya ito yung x sub 0, x sub 1, x sub 2, x sub 3, and this is the x sub 4. So para malaman natin kung hanggang saan lang yung multiplier natin for this coefficient, all we need to do is tingnan kung nasan yung coefficient natin. So ito yung row ng coefficient natin. So therefore, yung multiplier niya is dapat hindi sumobra or hindi pumantay dito sa row kung saan kinuha natin yung coefficient. So kaya for this coefficient, the a sub 1, ang multiplier lang niya is hanggang x sub 0, so hanggang 100 lang. Hindi pwedeng umabot ng x minus 150 kasi kapantay na siya ng coefficient natin. So parang ganun lang yung kailangan natin tandaan para ma-establish natin yung pattern when it comes to considering the multipliers for our coefficient. So gawin na natin. So we have our a sub 1, which is ito, Then, multiply. Pag multiply, we need to use the symbol asterisk. Doon. Ang x natin dito is 225. So, 225 minus x sub 0, which is 100. And then, tapos na tayo dito sa term na to. So, dito naman, so plus a sub 2. Ang a sub 2 natin is ito. And this time, yung mga multiplier niya is hanggang x sub 1 kasi hindi dapat pumantay sa row ng a sub 2 na coefficient natin. So, kaya hanggang dito lang siya. Hanggang sa 150 na value lang. Hindi pwedeng umabot ng 200. So, times. So, again, ulitin lang natin to. So, x minus 100 and then multiplied ulit by x ulit. This time minus 150 naman. And hanggang dun lang. Kasi hindi pwedeng pumantay sa row kung saan nandun yung coefficient natin. And then plus ulit. This time a sub 3 naman tayo, which is ito. And then times. So again, ulit na naman tayo. So 225 minus 100 and then times 225 ulit minus 150 and then times 225 ulit. Tapos nakalimutan ko na gawin ng parenthesis. So 225 ulit and then minus 200 na yun. Hanggang dyan lang. Kasi nga, sabi ko, hindi siya pwedeng pumantay dun sa row kung saan nandun natin kinuha yung coefficient ng term na to. So, therefore, hanggang dyan lang tayo. Therefore, and to establish the last term, so yun, plus ulit tayo. And this time, a sub 4 naman. And the same thing, ulitin natin. And para hindi na natin ulitin, actually, we can just copy this one hanggang dito na to sa kaya pwede ko itong copy na so dito. So hanggang na yan dito. Okay, hanggang na yan dito sa my x of 3. So ang isa na lang yung idadagdag ko dito, which is times x ulit. Oops, the parenthesis x then minus 250. And hindi ko nga isasama si 300 since yun nga, papantay na siya sa row kung saan ko kinuha yung coefficients ng term na to. And therefore, eto na yung parang interpolating polynomial kung saan sinubstitute na natin yung value ni x. And kapag pinag-press ko yung equal, automatically, masasolve natin yung pinapahanap na value ni y. So, to do that, pag equal ko, therefore, it will give me the value saying na at x is equals to 225 degrees Celsius, the value of y is approximately, or I think this is the equal value already, or the exact value already, 2.845469 millimeters. So, yeah. So that's how the Newton's divided difference method works when it comes to in polynomial interpolation. So, pina-follow lang natin itong general formula for the interpolating polynomial and makukuha na natin yung makukuha na natin yung equation na pwede nating magamit in order to solve for the value of y at a certain value of x. So, bakit at a certain value of x lang? Kasi, itong range of x natin is, ang pinaka-lowest niyang value is 100. So, therefore, hindi na tayo pwedeng bumaba pa ng 100. And, ang pinaka-maltaas na value niya is 300. Therefore, hindi na tayo pwedeng tumaas pa ng 300 na value. So, kumbaga, pwede lang natin na kuhang value ni y at a certain values of x is yung value, yung range lang ng values natin is from 100 to 300. So, beyond that, hindi na natin pwedeng makapag-value ni y or ibang value na or maling value na yung ibibigay niyan since yung interpolating polynomial natin is it only accounts for these values of x. Hindi na pwedeng lumampas pa sa range na to. So actually we can check if tama yung interpolating polynomial natin. Kapag binago natin yung value ni x, magbabago rin yung value ni y. So let's say for example, kapag nilagay ko is 100, ang lalabas na tayo sa 1.24. Pag 150 ba nilagay ko, 1.56 ba? So in that case, check mo if tama ba yung nilagay mong formula dito for the interpolating polynomial. So let's try to do that. So pag ginawa, gawin ko itong 100, 100, so equal. So therefore, nabago yung value ni y and it gives us 1.124 which is equal. Kapag ginawa ko naman itong 150, so it gives us 1.86, or kapag gawin ko itong 300, so lang. So it will give us 3.92, but yung problem is pinapahanap sa atin yung value ni y kapag daw si x is 2 to 5. Therefore, meron tayong sagot na 2.845469. So, ganun lang naman mag-work si Newton's divided difference method, and it works perfectly even if we are trying to solve for the value of x when y is given. So, ang kailangan lang natin gawin is pagpalitin lang natin si x and y. So, kumbaga, dito natin si y, dito natin si x. And ulitin lang natin yung process. Similarly, kung paano natin ginawa yung pag-generate ng mga values na to kapag yung form natin is naka-xy. So, kumbaga, pag ito pinagpalit natin, magiging yx. So, ito magiging inverse delta x, inverse delta squared x, so on so forth. And then, same thing lang naman, parang ganoon lang din yung gagawin natin to generate the interpolating polynomial by just following the general formula. And eventually, makakapag-craft tayo ng equation wherein kapag pinag-substitute natin yung any value of y, makukuha natin yung value ni x. So, I think that's it for the Newton's divided difference method. So, ito lang sa slide. And so, that's all for the Newton's divided difference method. So, I've already included here the summary of the table as well as the computations kung paano nag-arrive tayo doon sa value ng binigay sa atin ng Excel. So, here is the interpolating polynomial na nilagay ko dun sa Excel, or kumbaga ito lang din naman yung pinag-follow ko na form. And ang pinagkaiba lang is using the Excel, pwede kong makompute si value ni y with ease. So I think that's all for the Newton's divided difference method.